We're going to talk about how to generate NFT collection using the Camo Crocs NFT engine. First of all, who am I? I'm the founder of a few NFT projects listed here: Camo Crocs, Camo Crocs Signature Edition, and Dual Crocs. I also did the development for all these, and I have recently open sourced my NFT generator code. Why did I do this? When I started working on NFTs, there was very little information to go around. Uh, I had to ask a lot of people, put together pieces of information to do what I did. But these days, things are a lot better. We have Hashlibs, Boring Bananas, all these people have open sourced their code, which is great. So I decided to add mine to that list. My goal here is that non-technical people should be able to just change the configuration file and run a command and get the output they want without having to go into code. Also, if you are a person who is interested in the technical side, but you're a new programmer or something like that, you should still be able to benefit because I've written this in a fairly modular way. You can focus on parts of the code, try to understand what it does, and then see how it connects to the next part, than being overwhelmed by hundreds and hundreds of lines of code in the same file. I also wrote it in Python, which is one of the easiest languages for a new programmer to learn. So that should make it easier to read through the code. Uh, Here is how it's going to work from now on. In this video, I'll first download the code, set it up, and then just run it to show you that it is working. Then I will change the layers, the configuration, everything. So just like you would do when you want to use it for your project. And then we will see how that affects the output. And I'll explain a little bit about the configuration options. Then I'll go a little bit into the code structure just to give you a head start if you plan to look into the technical side. I will include some documentation on GitHub as well, so this should work in addition to that. All right, so let's go to the next part. Start using this engine, you need Python. The first thing, go to Google and then say download Python and install Python for the platform of your choice. I use a Mac and I have version 3.9. You should try staying close to that. Okay. It's pretty easy to find instructions to install Python, so just do that. After that, you can verify that you have the right version by typing python dash dash version. Okay. So I have 3.9.6. Right. Once you do this, you can now download the project. Go to the GitHub link I've included in the description, and then code and download. After downloading, I'll create a temporary folder and then move. All right, so now I'll unzip this file. You can see that there's a new folder. Go in there. You see this output here. Now, before I go into any of this, we first need to install the requirements for this project. The requirements.txt has all this. You can see there's not too many, there's just one. I have already installed this, so I don't need to do it again. But what you would do is say pip3 install -r requirements. So if you did this, it will install this one requirement for you. Okay, you can verify that all these are installed by typing pip freeze. Okay, so it shows that I have this installed. Now that this is done, let's look into the folder a little bit. So you can see that there is a layers folder, and then there's a config.json. These are pretty important. Layers has the artwork, the base traits that you would work with. I'll show you a quick peek. You can see there are a couple of backgrounds, eyes, one face, headgear. These are low resolution versions of the Doodle Crocs project, just a subset. And with this number, you can just generate about 5 images. This is just a test. You need to replace all this with your own artwork at some point. Okay, so with that, um, I'll open up config.json. I'll go deeper into this, but for now, you can see that the layers are declared in order, and then I have requested that 5 images be generated in the folder called output. Okay. The structure is the config file and layers, folder ordering. All these are kind of similar to hashlibs, but not exactly that. Uh, the the goal is that if say you want to switch from one engine to another for some reason, you shouldn't have to rework the folder structure too much. So it's why I try to keep things somewhat similar. Okay. Now that we have this, let's just go ahead and run Python Camo Crocs engine.py. All checks passed. Now let's open output. All right. Here you can see that images folder has the 5 combinations we requested, or 5 unique combinations. That, and then the thumbnails is just an option you can use if you want. If you, for example, you want to use a lower resolution version for promotions or Twitter or something, then you can ask the engine to generate the thumbnails as well. And then there's metadata, which is you have one per image. If you open up, you can see that it has been derived from the config file that we had. Okay, so these are all the attributes specific to that combination. Okay, this is just a quick teaser for how things work, but we will, next step is that we will replace the layers and um, configuration with something bigger, and show you that things work, and we'll go deeper into the config file and look at different options. Now we're going to learn how to customize the project for your needs. As a reminder, this is what we're working with. I'm going to delete the output folder. We will regenerate it. And then we have layers and then config. I'm going to replace both with a different set. So for now, I will delete this. And then I will copy other one. Okay, I will open the layers to show you that there's a lot more here. This is from Camo Crocs project. You can see that there are many combinations. Now with that, we will start looking into the JSON file. Okay. Now, what is the first thing? So you can see that there is a section called layers, and this first option, layer base path, is where you have stored the layer folders. Okay, we'll talk about the rarity delimiter in a little bit. And now the layers in order, this is where you list what order you want each trait to be blended. For example, the background comes at the bottom, and then comes the body, then the clothing, the outer clothing, and then face, eyes, and head and mouth and hand. Okay, so that's the order in which the images will be blended. Okay? And these should match the folder names you're using inside the layers folder. The next section is output section, where this is where the output will go, the output folder. And then here you choose the total images you want. This has to be within a limit that is that, I mean, it just depends on how many traits you have. Based on that, you can only generate so many unique images, and you need to do the math and make sure you're within that limit. Okay. Now there's image options. So here, within the base output folder, you are going to get a folder called images, and this is where the unique images will be generated. You can change this folder if you have a reason for it. The format, you can do JPEG or PNG. If you are using JPEG, this attribute will be used. This is the JPEG compression quality. The lower it is, the worse it is going to look. So it's a trade-off between size and quality. And this is the width and height of the generator output. I am setting it to 2048. Okay. Now you have an option. If you want to generate thumbnails along with the main images, say for Twitter promotion or something like that, then you can set the generate thumbnails to true. If you did that, you would also set the thumbnail options. So this is the folder, the thumbnails is the folder that the thumbnails will go to. And then once again, format, JPEG or PNG, the JPEG quality, and then you can see that I've set the width to 400 by 400, which is much smaller than the original width and height. Okay, if you set this to false, then none of this will matter. The data options. So here is where the metadata files will go to, this metadata folder. You can change it if you want. And then the format is either Solana or Ethereum. Solana has a few extra attributes you can include. I'll talk about that in a bit. And then name, description, external URL, all these are general attributes that all blockchains use. If you don't have a URL, you can leave this blank. The extras, this is used for Solana. You can add a symbol, and then the royalty you would get for secondary market. 500 means 5% royalty. And then the addition, just leave it to 0. I am not sure if marketplaces check this at all. Then there is creators. So for example, on Solana, if you want to split the secondary market royalty between multiple people in the team, then you can use this to say, okay, the wallet 1 gets 50%, wallet 2 gets 50%, and so on. So this 5% royalty will be split in this ratio between these wallets. If you are the only one, then you can just put your wallet in here and then change it to 100%, and then delete these if you want. Okay, so that's creators. And this is a little more advanced. You don't have to use it, but I'm going to explain it anyway. The concurrency, if you set this to true, which is the default, images and metadata will be generated out of order, which means it will use some parallel processing and get things done faster. But it also means that images and metadata will appear in random order. It will not be like the first image that gets generated is 0, the second is 1, and so on. It would do things in different order than you can predict. So leave it to true because it's just much faster doing it this way. And the random seed. So if you want to replicate the same set of unique images during multiple runs, for example, if the first time you run it and then you run it the second time, you will find that the images are totally different. That's because there's a randomizer in there which is generating different combinations. But if you want the same thing to be generated over and over, then you can set the random seed to true, and then you can set this value to anything, but it has to, as long as this is the same combination will be generated. I've set this to a long number. This is actually the last block minted on Ethereum blockchain, but you don't have to set it that way. Just set it to whatever you want, and it will you will be able to repeat this during every run. Okay, and then I think this is it. This is the end of the config. Um, we can now go and run once again. On the images, you can see that we have some combinations here. Okay. Now we'll briefly talk about what these two files are. Um, as you know, the metadata has a separate JSON file for each image generated. You can see that the attributes here are different from what we saw earlier. Okay. Now the underscore metadata is an aggregate of all these. So you can, if you want all the metadata in one place, then this is where you would look. You can see that the token ID 0 tells you all the attributes for the first image, token ID 1 for the second image, and so on. Okay, so all you can check, you can get a glimpse of everything in this one file, all the metadata. All right, the stats.json is just for your information. So this tells you, for example, how, if you have a question, how many times was this particular tiger attribute was used in this whole thing, then this is the you're going to look into this file and you get the answers for those. For example, you can see that for the eyes, the alien glasses was chosen only once, whereas the 3D glasses were chosen twice. Okay, and likewise for the headgear, the helmet was chosen thrice, and then the rest were chosen only once. Okay? You could parse this file if you want to do a rarity calculation, uh, but you don't have to. It's just informational. Okay. All right. Now we'll look into this one option that we missed, the rarity delimiter. So by default, if you don't do anything, if your images, the base traits are going to be chosen in um, with equal probability. For example, if you have this many background images, there is an equal chance of any of these appearing in any combination. But most people doing NFT collections don't want that. They like to have different rarity values for the different images. Okay, so for example, let's say that we want to give this deep sea background a really high rarity score. For example, you want this to appear only 1% of the time, but um, the rest of the images can appear with equal probability. So what you would do is you would name this differently. You would say deep sea pound 1. Okay, this means this image is going to appear only 1% of the time when any background is chosen. And let's also make Wild West another rare background. Let's make it say 5. It means in the entire collection it would appear only 5% of the time. Uh, and let's make, for example, this background like super rare, and then um, make it 0.5. Okay. Now, what about the rest? You don't have to go around naming each one differently. The engine will first check if you have a rarity delimiter here, and if you did, it would use that value as its rarity. But if you don't specify anything, it will simply distribute um, the rarity equally among the remaining. So for example, if you did this and you ran the generation again, um, let's wait. Now if we open the stats file, for example, then if we check how many times deep sea was generated, you can see that it didn't even use that value because we gave it a really low rarity score. I think to make sense of it, you need to have more images. Let's make it 50. Okay. And to make it a little faster, I am going to cut down the resolution just to 512, 512. Now you can see that things are being generated out of order because of the concurrency option that I explained earlier. Okay, now once the images are generated, we'll go into output. You can see that the stats is already generated. The images are being generated later, so it doesn't matter. All we care about is stats right now. If you go in here, you can see that Wild West was generated 5 times, and then you can see these other things. But you notice that Deep Sea was never picked, and the blue vignette was also never picked. That's because we really lowered their probability score, so which means there's less chance of them being picked. Maybe if you have thousands of images, it would have appeared a few times, but that's probably why they never appeared in this collection. Okay, so that's how you set the rarity. If you did not, everything would be used equally. If you did, you need to just go and add the pound sign and then the probability score. But what about the case where you you don't want a trait to appear at all? For example, if you go into hand, we have a few here. We have flamethrower, and we have this, and then we have a revolver. All these. Okay. Now we don't want we don't want the hand to appear at all in um, several images. How do we do that? You can create a blank image. I've called it none, and this is basically an empty PNG file, transparent. So you can put that in as one of the options. Okay. Now let's say you don't want a hand appearing 75% of the time, so I would just say none pound 75, and then I would do Volver maybe another 10% of the time. That makes it 85, and let's make this 5%, that makes it 90, and this is the 10 more, so that makes it 100 totally. I hope 15, yeah. Now if you let's first check what how many of these appeared earlier. Okay, here you can see that they've all appeared equally, almost, like 13 times, 13 times, 12 times, 12 times, right? So these are all similar in probability. Now if I rerun, all right, we'll let it run. What you should find is that the probabilities of the hand rates are quite different. I think this can run, and we don't need the whole thing anyway. We only need the stats file. Okay, I will go back. Now you can see that this is revolver is 5, and then flipping off is 2. So it means let's see, the sorry, not this, the base layers. Okay, if we go back here and we compare, you can see that the lowest probability here is this one, and you can see that it has been picked only twice in the 50, and then the flamethrower and revolver, both of them have been picked equally because we've given both a probability of 10. Okay, and the other one, the none, that has appeared the most number of times. So this is how you control the rarities. Okay, so now that this is clear, we are pretty much done with the configuration file. If you are only looking at just running this without knowing the code, I think you should be set at this point. You can even stop watching and go try this out. If you are using this for your project, let me know in the comments. I'll be happy to add your project to the GitHub link so that it gets more exposure. All right, so now if you are technical and you're looking at understanding the code as well, then we can go through the high level structure of the code now. I will not be doing a line by line walkthrough. If that's something you're looking for, leave a comment. I might make another video, but I'll be explaining the high level organization so it becomes easier to read the code if you choose to. Here is a high level architecture of the code. At the center of action is this Camo Crocs engine. This is the script that we've been running to get all the output. When this starts, the first thing it does is talk to this config parser module, which pulls the config.json and parses it and gives back a parsed configuration. From here, we go to this trait generator. This is a module whose job is just to get unique traits from the given configuration. Okay, it outputs an object that has information about all the unique traits for this project. Then from here we move to metadata writer. Now this one, its job is to accept the generated traits and the config, and then it'll go and write the .json files that you find in the metadata folder. Not just that, it also writes the stats JSON and the aggregated metadata. So its job is just to write all the metadata to the disk. Now this has some job of formatting the JSON for the blockchain that you've chosen. So it talks to a helper module called metadata formatter, which actually has a couple of flavors. One is Solana formatter and Ethereum formatter. Based on that, it picks one and formats the JSON and gives it back, and that gets written to the disk by this metadata writer. Now, once all this is done, the control comes to the image generator. This is the slowest part in the whole project. So this runs last after we have all the smaller files written out. Now this runs and then all the output images get generated. Once everything is done, there is a validator module. This has a lot of tests. It checks a number of things like it compares against the config, things such as do we have the right number of images we expected in the config, we have the right number of metadata files, and it also does some parsing of all the written out metadata and checks if we have the right number, and then it also checks the attributes and things like that. Okay, all right, so this is I might add more validations to this module eventually, but the purpose of this is that it verifies as much as possible what has been output so that you don't have to do this manually. look at the code just to show you that this matches with the architecture I just explained. So we have here the Camo Crocs engine.py, and then you can follow these steps. We have the config object created. So this has parsed all the JSON file, and we have all the parsed attributes in here. Then we have the trade generation. So we instantiate the trade generator object, giving it the config. Okay, and then at this point, trade gen has all the unique trades that have been generated. Then we write out the metadata by instantiating meta writer object. We give it the traits, then we give the config. Okay, so that gets written out when we call this metadata.write. After that, we instantiate the image generator. We give it the traits and the config, and we start. Okay, this will go and run the image generation, and this is the slowest step. After that, we run the validator. Then we call validate, which does all the checks. Okay. All right, so that's basically the flow. I don't have to go into each of these, but you can just see that the config parser is the one that has the config object, and then the image generator has the image object. We have the meta writer, and then we have the trade generator, and we have the validator. Okay. All right, so most of these files have a main method, so you can run each of those individually and just test parts of the flow. Okay, the model.py is one that has many data structures that are shared between all these modules. Okay, so most of these modules need model.py. I think that's pretty much it. The meta formatter, yeah, that one has this is the base class meta formatter. It has a sol meta formatter for Solana, and then it has ETH meta formatter for Ethereum. Okay, that gets used by this meta writer. Okay, so here it checks if in the config you have chosen Solana or Ethereum, and it instantiates the right type of object and gets the formatted output from it. Okay, and metadata writer also uses concurrency if you have enabled that in the config. Okay, so it tries to parallelize the writing of thousands of your metadata files when possible. Okay, it's not just exclusive to the image generator, the whole concurrent processing. Okay. All right, I think I have covered the code structure. At this point, you should be able to go look at the code and try to follow parts of it and see how it all connects together. All right, thank you for watching. If you have questions, I'll be happy to answer them. You leave a comment, and if you end up using this for your project, I would be really happy to hear about it and include your project name in the GitHub. Thank you for watching this video. Take a moment to check out the Camo Crocs projects. You can get them on Magic Eden Marketplace for Solana. And I hope you find the source code useful for your own work. Good luck.